Hi, this is Professor Pradyot from Leadib Academy. We are looking into IBDP Chemistry HL Paper 1, May 2019 video solutions. And interestingly, I'm not providing only the video solution, but we are going to discuss even the underlying concepts so that it would be some kind of a good revision to understand what are the underlying concepts so that you will have a better clarity. Okay, so it is not just the looking into the solution, but understand what is the deeper concepts. Okay, so it will make very interesting. And interestingly, we at Leadib Academy, we are providing the courses for the majority of the subjects of IBDP, like chemistry, physics, maths. So please do visit our website, leadib.com, okay, leadibacademy.com, okay, so that you will have a much better clarity. Okay, so let's start looking into the question number 31. Which is not a requirement of standard hydrogen electrode? You people have rightly guessed, it is from the redox. So what is SHE, She, standard hydrogen electrode? So let's look into it. Okay, so this is how you can think of what is the condition of SHE. Okay, so definitely it specifies the temperature 298 Kelvin. Okay, that is under which then what we do, we pump in hydrogen gas at 100 kilopascal, okay, almost closer to atmosphere, okay, almost close to, okay, and then there is a platinum electrode, okay, and then we take concentration of 1 molar H plus, okay, so we provide the solution. So now let's start looking into it, what is given. So in this case, option A, what are the requirements? Volume of 1 dm cube. Are you seeing anywhere the volume? No, we are not seeing any thing about the volume. There is no specific requirement. So definitely it is not specified. But let's see whether other parameters are being specified. Okay. Hydrogen pressure is 100 kilopascals. Absolutely. Okay, it is given. 100 kilopascals of hydrogen gas. So yes, this is there. Use of platinum. Is it mentioning? Yes, very much. Platinum electrode. Okay. This is the platinum electrode. So definitely it is there. Okay. And then H3O, 1 mole DMQ. Are you seeing anywhere H3O? Okay. H3O plus. Yes, because as I told you, H plus and H3O plus, they are equivalent. Okay, and we have seen many times. H plus, that is the proton, it can exist or it does exist like H3O plus, that is the hydronium ion. Okay, so they are equivalent. So this is also correct, and its concentration is 1 molar dm cube. Okay, 1 molar. Okay, 1 mole dm per dm cube. That means it's a 1 molar. So all these three, but this is not the condition. It doesn't talk anything about the 1 dm cube volume. So the correct option is A. So again, we are emphasizing that your concepts or your definition about this important concept should be clear. Okay, like SHE. So what are the conditions? So what are the conditions? 100 kilopascal pressure, platinum electrode, 1 molar concentration of H plus or H3O plus, aqueous solution. Okay. And temperature is 298 Kelvin, but it is not specified in this, but it could have been. Okay. So you need to be very clear. Okay. So that's a very interesting question. Okay, let's look into the question number 32. What is the IUPAC name of the following molecule? Simple. What we should do, the first rule, find Okay. Oops, sorry. Okay. So what this rule says, find the longest continuous carbon chain. Okay, that is the first thing. So let's do it. Which is the continuous longest carbon chain? You people are smart enough and have understood that this is going to be the longest carbon chain. And you can clearly see that there are 5 carbons. So the option has to be a pentane. So we can shortlist either this or this. That is B and D. A and C are straightway out of the race. Okay. Now comes the next part. Now we have to start numbering it. So what is the concept? Please remember, this is basically haloalkane. Okay. So the numbering has to be that so that the functional group, that is a bromine, should get the lowest possible number. So obviously we have to start numbering from here. 1, 2, 3, 4, and 5. So what it says, simple. That means on the second carbon atom, there is a bromine. So 2 bromo and followed by 3 methyl, because there is a methyl group which is attached on this third carbon. Please see this carefully. Okay. So that means 3 methyl pentane. Very, very simple. Okay. So 2 bromo hyphen 3 methyl pentane. Okay. That's all. So the correct option is D. So what 2 rules we have seen? That this was the first one, and the second, that functional group should be assigned to the lowest possible carbon number. Okay, that's all. So this is the answer. 2 bromo 3 methyl. That means the correct option is D. Very, very simple. Just follow the IUPAC nomenclature. Okay, very, very simple. Let's look into the question number 33, again of organic chemistry. Which is a major product of electrophilic addition of hydrogen chloride to propene? So first and the foremost is to draw the structure of propene, CH3, okay, then CH, I'm purposely drawing like this so that it is easy to understand what is going to be the case. Okay, so this is the propene. And there is going to be electrophilic addition. So let's start drawing. Hydrogen chloride. Hydrogen chloride. I'm purposely showing like delta plus and delta minus. Why? Because chlorine is more electronegative. Okay, and so it is going to draw electron towards it, so it will have a partial negative charge and hydrogen will have a partial positive charge. Okay, so now let's understand what is going to be the case. So in this case, okay, these pi electrons, okay, are going to get shifted on one of the carbon atoms. Okay, so I'm just showing on this carbon. There could have been another one that we'll discuss. Okay, So if it happens, what is going to be the case? So we will get like this: CH3, CH. This will, okay, let me start. H, H, and let me show the charge. Since it has got the extra charge, so this will have a minus charge and this will have a plus charge. What do we call this plus carbon? That is called carbocation. So C plus means carbocation. That means it is deficient in electrons because it has gifted the electron to the neighboring carbon. Okay. So now we may have to decide. Now please remember that this carbon, even though it's a positive, it is basically can get a supply of electron from the adjacent methyl group as well as this negative charge, because if this carbocation gets formed, it can get supply of electrons from these two adjacent carbon atoms. So this carbocation is going to get stabilized, okay, because this is the carbon is having a plus charge. Carbon is not the electropositive element, so it is under distress. But there are two friends, that is, one is methyl group, okay. So methyl group can also supply electrons as well as the adjacent this negative carbon, okay, that is the carbanion, and it will get the electron supply from both. So it can remain stable because it is getting electron supply from its two friends. Now let's see if what would have happened if it would be the other way, okay? Because right now we consider this. Now let's imagine that, okay, it gets shifted in the other way. What does it mean? That means CH3, okay, this becomes C minus and this becomes C plus, okay, this. Now this has become a carbocation. Unfortunately, there is only one friend, okay, which is this minus charge. So this is not going to be stable, this form of carbocation, okay. That's why it is very important to understand. This is basically nothing but a Markovnikov rule, okay. Exactly. Why this carbocation is getting formed like this, okay. So very, very straightforward. So after that, it is very, very now simple that if this is getting formed, so now H plus will come on this and Cl minus will come on this carbon. Okay, so which compound we'll get? Very simple. CH3, CH, CH, H, and let me show with the different color that this will have Cl and this will have H. Okay, simple. And we will get this compound. So simple logic. So CH3, CH, Cl. Okay, so the correct option is B. And this is nothing but we can say Markovnikov rule. Okay, so what Markovnikov rule says that hydrogen will get attached, okay, in this case hydrogen will get attached to less substituted carbon. When there is a breakage of the double bond, hydrogen will go to that carbon which is the lesser substituted. So in this case, clear cut, Okay, this carbon is less substituted. That means there is a lesser amount of hydrogen which has been replaced as compared to this, and therefore it is getting attached. Okay, simple. So this is called electrophilic substitution. Okay, not sorry, electrophilic addition. I'm sorry, electrophilic addition. Okay, of hydrogen chloride. Very, very simple but conceptual. So please remember to understand Markovnikov rule. Markovnikov addition. Okay. If you want more details, you can always refer to our courses. Okay, because we are providing the courses for the majority of the subjects of IB, like chemistry, physics, maths. Okay, so please do visit our website. Okay, leadibacademy.com, where you will find these interesting courses. So please subscribe. Okay, and you will have a much deeper understanding of all these concepts. Okay, another interesting question from organic chemistry. Question number 34. Which alcohol would produce a carboxylic acid when heated with acidified potassium dichromate? So what we are talking about? Okay, very, very simple. Okay, so what is the concept which you need to remember? When alcohols are getting oxidized with acidified oxidizing agent like K2Cr2O7, first they will get to aldehydes and then further oxidation to carboxylic acid. But there is a condition that these alcohols need to be primary alcohols. So this is the very important condition. Okay, that these alcohols need to be primary alcohols, because primary alcohols can get completely oxidized to carboxylic acids. If it is a secondary alcohol, it will get oxidized only to ketone, while tertiary alcohols will not get oxidized under the normal circumstances. Okay, very simple. It means that our job is to identify, okay, out of these four, which is the primary alcohol. So let's look into the option A, propantuol. So it's simple, OH. So this is not the one, because this carbon, okay, this carbon is attached to two carbons, so this is out. What about the option B? Okay, so option B, butane, okay, one all. So 1, 2, 3, 4, and then let me show OH. Okay, so yes, this is correct. Okay, but let's get it confirmed whether it is there is nothing else. But I think you can clearly see that it is not there. Okay, because this is the methyl, okay, propanol. So there is a okay, OH and this. So this is also not there. And pentane 3 all, again, it is not the primary one. So this is also not correct. So the primary alcohol is only butane 1 all. Okay, so that is option B. Okay, option B is the correct option. Okay, so it is very, very simple. Okay, let's look into the question number 35, again from organic. Which solvent is aprotic? Okay, So what is mean by aprotic solvent? Simple. Okay, the solvent which can donate H plus or it can get dissociated, okay, and form or gift a proton when it is in the solution. Okay, so it should be in a position to get dissociated into H plus. So let's first look into the option A, that is the H2O. Yes, we know that, okay, because it can donate or it can get dissociated into H plus. So this is not definitely aprotic. Let's look into this C6H5. Interesting. This is nothing but, okay, a toluene. Okay, so let me show with the different. Okay, so this is how it is. CH3. This is the toluene. Can it donate proton? No chance. Okay, because these hydrogens are attached to carbon, and we know that carbon and hydrogen, there is no electronegativity difference. So these bonds are not polar, and so it is not possible to give away these hydrogens. And on the benzene ring, no chance, because benzene aromaticity cannot be disturbed. Okay, so it definitely cannot gift, okay, a proton. So that means this is very much aprotic. Okay, but let's confirm whether other options are no more valid. So this is okay, methanol. So CH3, okay, OH. Yes, it can very much, because this is delta minus, this is this. So this can be very well gifted, okay, and it can basically donate proton or it can get dissociated into this. What about CH3NH2? That is basically methanamine, okay. So this is how it is, CH3s and then NH2. So very much one of the hydrogens can be gifted, because nitrogen is more electronegative, so it can basically give away this H plus. Okay, so that is the capability. So again, all can basically are, all these are protic solvents, exception is toluene. Okay, so the correct option is B. So again, what is important to first understand what is mean by aprotic, and then you should be having some fairly good idea about the structure. Okay, that's important. Interesting question number 36. Which statement is not correct? Okay, please understand, just be careful which is not correct about benzene. So what is the benzene? Benzene structure is like this. Okay, I'm just showing like this, simple. It is planar. Yes, this is the planar, because all these carbons are sp2 hybridized. Okay, and we know sp2 hybridized, that means it has to be a planar structure. So this is because the sp2 hybridization. Ring contains delocalized electrons, very much. Okay, as a matter of fact, delocalization concept or resonance concept was basically discovered by a famous Russian scientist Kekulé because of the benzene. Okay, so obviously it has a delocalized electrons. Okay, so this is also there, this is also true. It always reacts in the same way as alkenes, no chance. Okay, benzene is extremely stable. Okay, the reason being that there is basically this resonance, okay, this delocalized electrons, so it brings lot of stability, okay, and what we call aromaticity. And that's the reason that benzene is extremely stable. So it doesn't show, okay, this similar highly reactive reactions like alkenes. So this is not correct. That means this is correct. Okay, this is not the correct statement. Correct statement is not there. That means this is the correct option. And a carbon carbon double bond, okay, bond has a bond order of 1.5. Yes, the reason being that the actual structure is something like this. That means it is neither double bond nor single bond. Okay, the true structure or resonance structure of benzene is like this. So even though we are showing like this, sometimes the benzene structure is being shown like this, but that is not correct because it can exist even like this. Okay, so both these structures are basically alternating. So this, none of them is actually strictly correct. So the bond order is between 1, it is between 1 and 2, that is around 1.5. Okay, so again, this is the correct statement. So correct statement, so the only wrong which is not true for benzene is C. Okay, and therefore the correct option is C. Very simple. Okay, interesting question number 37. Which compound can exist as cis and trans isomers? Simple. Identify the compounds which are double bonded and they are not going to. Okay, that's the logic first of all. That means even this is out, there is a double bond, and double bond. So they are not going to exhibit. So this is correct, but let's try to understand how it will look like. Okay, so let me try to show the structure. Okay, so we can think like this. Okay, so let me try to show. This is CH3. Okay, and there can be another possibility like this. So obviously this would be a cis form. That means these two methyl groups are closer to each other, and there could be another form which is like this. So we will maintain methyl group like this and another this. Okay, so please remember this, you can consider this is like a plane. Okay, this is like a plane. So both these are above the plane, while here in this case one is below the plane. Okay, so you need to visualize. So this is basically a trans. Okay, that means these two groups are okay far apart, while in cis they are close to each other. But definitely for the double bonded one, it's a restricted rotation of the carbon. Okay, so that is a trick how to understand. So there is no possibility because the restricted rotation. So the only possibility will exist in this case. Okay, so the correct option is C. Simple. Cis form, trans form. Okay. Question number 38 from measurements. How should a measurement of 5.00 gram from a balance be recorded? Okay. So what are the options? So what is basically the understanding? Please understand that when the reading is recorded like this, what does it signify? That means this two decimals are indicating that we can go up to 0.01 gram. Okay, that is basically what we call a least count. Okay, so it means simple that we can record like this 5 plus or minus 0.01. That's all. Okay, it's very simple. So the correct option is B. Straightforward. You can look into it that none of them is correct. Important part that 5.00 gram means that the least count or whatever is the least possible measurement is 0.01. Okay, that's the logic. Okay. So the correct option is B. Extremely simple. Interesting question number 29. The dotted line represents the formation of oxygen, okay, from the uncatalyzed complete decomposition of hydrogen peroxide. Okay. Which curve represents a catalyzed reaction under the same condition? Okay. Very interesting question involving both kinetics, chemical kinetics, and equilibrium. Okay. So let's understand. So let me show with the different color. This is okay, this is uncatalyzed. Okay, dotted one. Okay, let me, I think I haven't drawn properly. Let me, okay, let it be the dotted one. Now, when it is a catalyzed one, okay, what is the concept? In case of catalyze this one, catalyst basically what it does. So what are the characteristics of the catalyst? It speeds up the reaction. And second most important, doesn't alter the equilibrium. Very important. Okay. So speeds up the reaction. That means the initial rate of reaction has to be higher. So that means straightway C and D options are out. So we need to evaluate only between B and E. Okay, that should be very, very clear. Okay, you should be in a position to eliminate at least 2 options out of 4. So in this case, the toss is between A and B. Okay, because both are qualifying. The reason being that initial rates of reaction. What do you mean by initial rate? That means how steep it is initially. So basically, it is nothing but the slope of the tangent. Okay, so you can clearly see A and B initially they are rising much faster as compared to dotted line. So yes, that is qualifying. But the second criteria now comes into play that doesn't alter the equilibrium. So what is happening in case of A? That it is achieving at equilibrium much higher volume. Okay, this is the equilibrium condition, but it is producing much higher volume. That is, catalyst doesn't do that. Okay, catalyst doesn't alter the equilibrium at all. Okay, so that's why it has to qualify both. But in case of B, the equilibrium is almost achieved at the same time as compared to the uncatalyzed reaction, because the volume which is getting produced, okay, of the oxygen is going to be almost similar to this dotted line. That means the B is the correct option. So what you need to consider, both the factors. Catalyst speeds up the reaction, so initial rate of reaction is higher. Okay, and second, that it doesn't alter the equilibrium. Both the factors. Okay, so the correct answer is option B. Okay, very good quality question. Okay, so both the concepts should be very, very clear. Question number 40. Okay. Which can be identified using IR spectroscopy? Straightforward, the answer is functional groups. Okay, the clear-cut answer is functional groups. That is whole idea about IR spectroscopy. Okay, so it is straightforward, information based. Okay, functional groups, we can identify whether it is like C double bond O or OH or any other type of functioning. Okay, and these are mentioned in the data booklet, so you can refer to, but this is the characters. Okay, this is what is the direct application of IR spectroscopy to find out the functional groups which are present. Okay, we can determine the molecular structure by knowing the functional groups. Okay, whether there is a double bond between carbon and carbon, or single bond, or carbon and oxygen double bond, etc. Okay, so it's a straightforward. Okay, so the option is A, and you can very well look into our course in which we have explained all this measurement and data processing and our courses. Okay, so please subscribe. Please do visit first of all our website leadibacademy.com, where you will find our courses. Okay, and we have covered, and besides that, we at Leadib Academy, we provide one-to-one online teaching also to get your concepts crystal clear. So we can help you in all the aspects. Hope you enjoyed this session. Thank you.